Hello everyone, I will go ahead and help you with your experiment 7 pre-lab. I already posted the handout on Blackboard, but this is also going to explain you how to do those calculations. So your question 1, you are given a Buret measurement, okay, and it look like this. So you have a Buret. Let me draw it over here. You have a Buret like that, okay, and then in the Buret you have a liquid. So you can look the image. I was not able to copy it here, so I'm going to go ahead and draw. So this is your 20 point mark and this one is 21. So then the bottom over here, the middle one should be 20.5. And then you have 4 marks, 1, 2, 3, 4. 1, 2, 3, 4. Right? And then the liquid level is like this. I think it's right like this. And this is all your liquid. The green one is your liquid. Okay? Alright, so you need to figure out how would you read this one. And it says the smallest division of the Buret is 0.1. Meaning, so each little mark over here is 0.1. So the green ones that I'm drawing, they are 0.1. These are 0.1. Okay. So 20. So the green color is what you have the liquid inside the Buret. So how would you read the Buret? So you always read from top to bottom, not from bottom to top. You take the 20 and then you go by. So the first one would be 20.1, 20.2, 20.3. 3 would be here that I'm showing you here. And then 20.4 would be here. But the liquid level is a little bit about the 20.4. Okay, and also says the Buret read up to 0.1. So what you can read is 20.1, 20.2, 20.3, 20.4, 20.5. You can read like that. That's what the Buret reads. But remember, each instrument or each piece of glassware that we use carry one more digit in addition to what it is given as the marked value. So we can go one more significant figure, meaning in this case it would be one more decimal place. So we can go up to 20.10, 20.20, 20.30, 20.40. If it is exactly lining up at 20.4, so then the answer should be 20.40 by adding one more significant figure to the marked divisions or the marked lines. Okay, we are not given 20.40, so that is not the correct answer. So what is closest is has to be up to 2 decimal places, so that should be then, so this is 20.3 here, so then it should be 20.3 plus another number. So the closest would be 20.38 because of that. Remember, it's not 21.6. Not reading from the bottom to the top. So this is going to be 20.5, this mark. Right? Always you read from top to bottom. Meaning how much liquid is inside the Buret. That's going to be your volume. You'd read it from the top to the bottom. So this would be 20.38. Okay. The next one, in no more than a sentence, explain why important to add 2-3 drops of phenolphthalein. Well, phenolphthalein is the indicator, right? For when you are doing any kind of a titration, especially when you are using liquids that they are clear or colorless, we always have to use an indicator. Indicator will tell us when it changes from one medium to another one. For example, acidic to basic or basic to acidic. If you do not have the indicator added, what will happen? You will keep on adding your titrant, nothing will happen. We will not find our end point or the equivalence point. So in order to find the equivalence point where the color changes, we have to add a few drops of indicator. So you can explain that in your own words for question number 2. Question number 3. In part 1 of this experiment, you will standardize the sodium hydroxide solution by using in a titration with hydrochloric acid of known concentration. Suppose that you transfer 10 milliliters of 0.1106 molar hydrochloric acid into an Erlenmeyer flask. Okay, let's say this is going to be in the Erlenmeyer flask. You add 10 milliliters, right? 10 milliliters, 10.00 milliliters, and the molarity 0.1106 m into Erlenmeyer flask. And then you add 25 milliliters deionized water. So you add 10 milliliters HCl plus 25 milliliters water. Okay, how many moles HCl are present in the flask at the beginning of your titration? So when you add 25 milliliters of water, does it going to change the number of moles of hydrochloric acid? No, it does not, right? Because we are adding just water. But if you try to calculate the molarity, then it would change. So how would you calculate the number of moles? Remember our equation, molarity equals moles over volume in liters. So then the moles are going to be molarity times the volume in liter. So molarity is 0.1106 moles per liters time the volume is 10 milliliters. So I'm going to go ahead and erase this to get some space here, times the 10 milliliters, 10.00 milliliters, and always you want to convert milliliters to liters. So 10 to the power 3 milliliter equals 1 liter, right? So milliliters to milliliters cancel, liters to liters cancel, we will have the number of moles. So you can do this calculation and see what answer you're gonna get. Okay, so you can write that down. 0.1106 times 10 over 1000. So when you do this calculation, you will get an answer similar to 0.001106. And as always, make sure you also do the calculations without depending on the number I get, because sometimes my calculator also act weird, so I might get a different number. So make sure you perform the calculation and check to see you also getting the same number. And if you find it's different, just let me know, send me an email so I can correct it. Okay, so that's the number of moles. And then if you need to enter the number, yes, if you need to enter the number, okay, so let's say you want to enter this as scientific notation, so you can move it 1, 2, 3. You're moving it 3 times, so that would make it 1.106, and then you put your E. If you move it to the right, is it going to be positive or negative? See, you have a smaller number and then you are making it a bigger number, 0.001106, now 1.106. So it has to be negative, right? Negative exponent. How many times did we make it? 1, 2, 3. So E negative 3. right? So that's how you would put that number as an exponent. Point either 0.01106, or you can put 1.106 E negative 3. Okay. And then the next question. Suppose you titrate the HCl solution described in question 3 with sodium hydroxide of unknown concentration. Okay, so now we are going to titrate this hydrochloric acid in the flask. Over here you have hydrochloric acid. Now you're going to titrate with sodium hydroxide. At the beginning of the titration, your initial volume reading from the Buret is 0.52. Let's say this is your Buret, and you have your hydrochloric acid in the flask here. This is HCl and sodium hydroxide here. Your initial Buret reading is 0.52. That's 0.52 at the beginning. At the end point, when the solution in the Erlenmeyer flask turns pink, the final reading is 14.16. So somewhere here would be 14.16. What was the total volume of sodium hydroxide solution added to reach the end point? How do you calculate that? You take your 14.16 milliliters and you subtract the initial volume 0.52 milliliters. And we are doing a subtraction. Remember, we go by the least number of decimal places. So there are 2 decimal places. So when you do that, it would be 13.64 milliliters. So without the units, you can put your answer right there. And then question 5. How many moles of sodium hydroxide were used to reach the end point? Think about the balanced chemical equation for the neutralization reaction between HCl and sodium hydroxide. Remember, you calculated the number of moles of HCl present initially in question number 3. So if you look at the balanced equation, HCl plus sodium hydroxide, we are making sodium chloride and water. It's a 1-to-1 reaction. Molar ratio is 1-to-1. 1 mole of HCl react with 1 mole of sodium hydroxide. And earlier in question number 3, we found the number of moles of hydrochloric acid, which is 1.106 E negative 3. So since the molar ratio is 1-to-1, so then the number of moles of sodium hydroxide also would be the same number, which is going to be 0.001106, since the molar ratios are 1-to-1. Okay. And then the next question, use your answer to question 4 and 5 to calculate the molarity of the sodium hydroxide solution. So we found here number of moles, and we also know the volume of sodium hydroxide from question number 4. That's the volume, and this is the number of moles. And we are going to now find out the molarity. So what is the equation for the molarity? Molarity is moles over volume. So we found the moles 0.00106 and the volume 13.64. So we can now calculate the molarity, right? So molarity would be moles over volume 0.001106 moles. You divide by volume 13.64. Remember, 13.64 is milliliters. So you always convert it to liters. When you convert it to liters, it would be 10 to the negative 3, right? Because 10 to the negative 3 liters equals 1 milliliter. Okay, so you do this calculation and get the answer. You will get something like this. But again, do not depend on my answer. You do your own calculation and see what you're going to get. So that would be the molarity of sodium hydroxide. Okay. Now the next question 7. In part 2, now we are done with the first titration. So the second titration, so the first part of this titration, what you are doing is you're trying to find the concentration or the molarity of sodium hydroxide using HCl, right? Now we use this sodium hydroxide, the concentration that we already found, to do a titration with sulfuric acid and find the concentration of sulfuric acid. That's what we do in the part 2. In part 2 of this, you will use a standardized sodium hydroxide solution in a titration with H2SO4 of unknown concentration. Balanced chemical equation for this reaction is written below without coefficients. Excuse me. So you have sodium hydroxide. If you draw the balanced equation, there would be sodium hydroxide plus sulfuric acid H2SO4 giving you sodium sulfate Na2SO4 plus water. It's not balanced, so you need to balance it. How do you balance it? There are Na2SO4, you put 2 here, and that made 2 oxygens, 2 hydrogen, right? So to balance that, you put 2 in front of water plus 2 water. Now it is balanced, right? There's 1 sulfate, 4 hydrogens, 2 oxygen. Now it is balanced. So you put the coefficients, okay, next to that, next to each one. So in front of sodium hydroxide would be 2, sulfuric acid 1, Na2SO4 1, and water 1. Okay, so you need to find the coefficients. Question number 8. 10 milliliters of the unknown sulfuric acid titrated with standardized sodium hydroxide. Now you take 10 milliliters H2SO4. Remember earlier we used hydrochloric acid. Now we have sulfuric acid 10 milliliters, and you're going to titrate it with sodium hydroxide. In the Buret you have sodium hydroxide. Okay. 10 milliliters unknown, titrate with sodium hydroxide. The initial Buret reading at the beginning of the titration was 0.28. So let's say the initial was 0.28. Final 37 point, somewhere here, let's say 37.08. How many moles of sodium hydroxide were added to reach the end point? So when you add sodium hydroxide, you reach the end point. We are given the initial and the final Buret reading of sodium hydroxide. So we can find out the volume of sodium hydroxide needed by the difference. So 37.08 minus 0.28. That will give us the volume of the sodium hydroxide, 36.8 milliliters. How many moles? How do you find out the number of moles? So we know the volume. Remember earlier we found out the molarity of sodium hydroxide in question 6, 0.08109. So use that to calculate the number of moles of sodium hydroxide. So then the moles would be molarity times the volume. Molarity times the volume. Remember from question number 6 we found the molarity 0.08109. Molarity is given moles per volume in liters, and 36.8, that's milliliters, so you need to convert it to liters, 10 to the negative 3 liters. So you multiply these two, 36.8 times 10 to the negative 3 times 0.08109. and that would be 0.002984. 2984 without units. You have to put 36.80. In fact, here it should be 36.80. I'm missing a 0 right there. 0, right? So 4 significant figures, 0.002984. That's a 0 right there. You got it, right? Yeah. So that's the answer for question number 8. So now we found the number of moles of sodium hydroxide we used to titrate sulfuric acid. So the next question, how many moles of sulfuric acid were present at the beginning of this titration? Type your numerical answer without units. Now the number of moles, remember we have the balanced equation here. 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. Molar ratio is 2 to 1. We found the number of moles of sodium hydroxide. So then what should be the number of sulfuric acid going to be? It should be half of that, right? Because the molar ratio is 2 to 1. So question number 9, 0.002984 moles NaOH, and the molar ratio is 2 moles NaOH react with 1 mole H2SO4. So basically this number you divide by 2. That will give you the number of moles of sulfuric acid. That would be 0.001492 moles sulfuric acid. And then the question number 10 would be, what is the molarity of sulfuric acid solution? Without units. Okay, so we found the number of moles here. And then we also know the volume of sulfuric acid. Remember what is the volume that we put it in the flask? It was 10 milliliters. So then the molarity would be 0.001492 moles. You divide by the the volume 10.00, which is in milliliters. You need to convert it to liters. That will give you the molarity of sulfuric acid. Okay, you can get the answer and type in there. So I think this help you to do your pre-lab calculations. Remember, I also posted a worksheet on the blackboard. Now this is the explanation how you get those answers. Okay, all right, then talk to you soon. Bye bye.